suppose you're given table of values of two functions f and g. So here, for example, f of -1 is 3, f of 2 is 5, and f of 5 is -1. I mean, if I were to write this, it's more confusing, right? So having it given as a table, it's easier to see the values of the function and its derivatives. Okay, so let's say we're given this table, and the question here is, if h of x is the composition of f and g, and p of x is f of x squared, compute these things: h prime of -1, p prime of 2, and h prime of 5. Alright, so let's try this. H prime of -1 is, well, h is f of g of x, right? So we differentiate this, and after differentiating, you have to plug in x equal to -1. I like this symbol, which means you calculate it first, and then you plug in whatever that's here. And that's necessary here because if you plug in first and then differentiate, if you plug in something into x, the moment you do that, it becomes a number, so when you differentiate, you get 0. So it doesn't make sense, but this h prime of -1 really means find the derivative first and then replace x by -1. So you really have to do differentiate, and then you plug in x equal to -1. Alright, well that's just the chain rule, right? The chain rule says treat g of x as like a big X, f prime of x. So f prime of g of x, and then whatever you called as the big X now has to be made a copy of. You make a copy outside, put the derivative, and multiply, okay? And then you're plugged in x equal to -1. So you have f prime of g of -1 times g prime of -1. And now we can just read the values. What's g of -1? G of -1 is 2, right? So this is f prime of 2. What's g prime of -1? G prime of -1 is -5. So it's -5. And then you realize you have to do f prime of 2. F prime of 2 is here, this negative, it's -2, so it's -2 times -5, which is +10. Alright. Now, for p of x, you have two ways to do it. For p prime of x, see, p prime of x is like fx squared prime, right? So fx can be thought as the inside function, so you're really differentiating x squared. X squared differentiates to 2x, right? But that's not x, it's really f of x. Then you bring this outside and you put the derivative, you differentiate it. So that's what p prime of x is. So you can get this. Now, if this looks confusing, there's still another way to differentiate it, which is to say that f of x squared means f of x times f of x. Everyone knows that, right? What's a square? That's like that thing times itself, right? But if you write it this way, then you can avoid having to use the chain rule because it's no longer a nested function. It's just a product. So you can use the product rule to differentiate. So which is f prime of x, differentiate the first, leave the second, plus leave the first, differentiate the second. And since they both look like f prime times f, you end up with 2 times f of x times f prime of x. So great, right? So either way you get this, therefore p prime of 2 would be 2 times f of 2 times f prime of 2. Well, f of 2 is 5, f prime of 2 is -2, so this is 5 times, oh, there's a 2 before, 2 times 5 times -2, which is -20. Okay, And finally, h prime of 5, well, we can just use the same thing. It's this, and you replace x by 5. That's what it is. So it's f prime of g of 5 times g prime of 5. G of 5 is 5, so you see that this is f prime of 5 because g of 5 is 5. So g of 5 is 5. G prime of 5 is 13, so you multiply by 13. And g prime of 5 is, no, f prime of 5 is 11. Okay, so you end up with 11 times 13, which is 143. Okay, so these are the answers.